I'm afraid to disappoint that I'm not an engineer, unfortunately. I've never gassed. I'm a mathematician. I've never even gassed a rabbit, so I'm afraid that there's time yet. There's time yet. So what we talk about is whole life costing, particularly as it applies to S&C later on. Whole life costing has become and it's always very important for network rail and the rail industry. We use our whole life cost models to help develop the policy, so the move towards much more refurbishment in CP5, the move towards more renewals in high criticality routes was justified and developed through whole life costing, and we had to put those models that we'd used in front of ORR to justify the funding. Now, there are some serious shortfalls in the models. I'm not going to pretend we've got something fantastic that we're using for what we're doing. We're still developing it. S&C in particular are a problem because they're very complex. Plain line, we feel a lot more confident, but S&C is such a complex thing, so many different sources of S&C, so many different issues they have, as you've already talked about today. Getting a good whole life cost model that we can use for all the types of S&C that we've got is very difficult, and we're still developing, and we're trying to use methods to develop those whole life cost models so that people here may be able to use them to work out what they're going to do with specific S&C. So whole life cost assessment, what is it? Well, it's supposed to look at the entire costs from cradle to grave. So we're talking about, in some cases, design costs. So when we're talking about enhancements, for example, when looking at, say, East-West Rail, we even think about the entire design of the railway. Any product development, so we're looking at, for example, doing whole life costing for the brand new NR56 design, which I'm sure will come out absolutely spectacular. Yeah, don't worry. Manufacture, installation, maintenance and renewals. Probably most of what you're mainly interested in here will be from this point on. The installation, maintenance renewals, etc. And a lot of the time what we're really considering, well, if we've got an S&C in its current condition, what can we do to improve it? How much is it going to cost to improve it? How much are we going to get out of that in the future? And I'll be talking a bit more about that later today. One of the drivers for the more detailed models that we're putting forward together, when I say more detailed, we only see the detail, don't worry, you don't have to do complex physical equations. We were criticised quite a lot in the past by ORR for not having any whole life cost justification for what we're doing, in particular on enhancements. And they said that if we didn't do any whole life cost justification for enhancements, we wouldn't get the money. So now every enhancement project that goes in front of ORR has to have a whole life cost justification. Some of them, so far, I'll be absolutely honest, have been pretty poor. But we are trying to improve them all the time by getting a standard way of doing the work. And that will include things like, say, the Derby remodelling that's about to happen, etc. King's Cross remodelling, Waterloo Station remodelling. That will all have to have a whole life cost justification. There is a whole life cost manual that's been developed by IP, and that is available on the intranet. 400 people have gone through the training course so far, and that training course is still available if you want to get a lot more detail on the model that we're using. So when are you going to do whole life cost assessments? Well, for enhancements, as I said, you've got to do them. If we're doing any sort of more complex renewals, probably have to do them. Anything more than £3 million, strictly speaking, have to do that as well. Smaller stuff, what we hope is that we've got an asset policy that has already had a whole life cost justification done for it. So we would say if you follow policy, and I'll talk a bit about policy for S&C refurbs later, then we could say that, as long as you're doing it to the cost that we've got in the policy, and I know that's a very difficult thing for some people, then that will be justification in itself. If you've got it within the budget, you've got the budget within the route, and you're going to get the specification that we put in the policy, then that's justified already. So these sorts of decisions we might do. When should we renew, or what should we do to an S&C, whether it's just a simple turnout crossover or tyre junction. What's the optimum maintenance regime over that S&C life cycle? So we're looking at very different ways of maintaining. Is it worth doing a lot more proactive renewal, a lot of more proactive work on, for example, the switchblades? A lot of the stuff that Neil was talking about before, I would say that's clearly a good idea, but possibly they don't even need to do much of a judgment on that. What should we do when we've got a major enhancement coming up? We know it's going to happen in the next 3 or 4 years, but we've got some S&C there that's already struggling. How do we keep them going? Because do we really want to spend £400,000 replacing each end for about 4 years when we're going to put it in a completely different place in 4 years' time? What can we do to keep it going? And I guess questions will be asked at Watford Junction at the moment, for example. Now we've just cancelled a major work. So the key elements, asset specification is probably the most important. So what is the asset doing? And that's more than just the design, it's where it's working. What line speed is it working at? What are the performance targets for it? So performance targets may even depend on where it's working. So you might have, I expect, extremely high performance on a high criticality junction. Might be prepared to accept a few more failures on somewhere in the north of Scotland, say. It was from Scotland previously. So,
only the RAM.
Yeah, only the RAM. Well, so what we mean there is a lot of the time we're talking about, say, can we survive with medium refurbishments on these old bullhead S&C that you've got in Scotland? And I think you're struggling with how to do those at the moment, for example. How much it costs. Well, sorry, I'll just go on this one first. Expected condition after work. Now that's a very important one. So we must have some idea of what the condition is going to be like after you've done all the work and how long that condition is going to survive. So I know whenever we get the contractors in, they always say it's going to be spectacular. Look at the record, how it looks 3 months after I've put it in. We're more interested, to be honest, in what it's going to look like 5 years after you've put it in. So those are the sort of we need to do constant assurance on any refurbishments that we've had done. I mean just as an obvious example, we for our high output, our track relay, we did quite a lot of track relay before we did any ballast cleaning on Western. And the geometry, without cleaning the ballast, I mean the ballast was not clean, we just did the merest of skims and consolidation of it. The geometry was spectacular after that. So if we just looked at that and said, and just some contractor come back a year later and said, well, Tratley, we don't even need to do ballast cleaning. Look at the record, we've got 1 millimetre SD there a year after. But the fact is, as soon as that got off, we would never have got it back again. So we need to keep constant assurance, not just the 2 or 3 months after the work has been done. And then we would expect that first set to come from people doing the work, the people who have been contracted or say the enhancement team. This bit here is the harder bit, the future life cycle costs. And what we're doing at the moment is trying to work out what those costs are based on historical record and a lot of engineering judgment for each different type of asset. Now, I can imagine on S&C that covers a huge range in terms of tonnage, line speed, design, etc. So we're trying to work out some rules. So we'd have some simple rules, so we could say if it's in this condition, we'd expect this sort of maintenance activity, these sorts of costs to be incurred. The big one of the big things we always ask about is expected service life, and those numbers aren't real either, but when people tell you that the expected service life of an S&C is 40 years, that's it, then don't believe that either, as you probably know. These numbers are the average service life we'd expect for various tonnages, equivalent gross tonnages per year. But even these, there's a massive variation that we'd expect on each S&C. So even though this is the NR60, we'd expect that to be quite high. In fact, we're very rarely going to get 50 years out of an NR60. We don't really expect it, because that would be 50 years, maybe if it was on a 40-mile-an-hour track. But of course, most of the NR60 are on much higher line speed tracks. We might only get 20 years out of it. And so what we've got to do is try to work out what the performance targets are, whether the design, the local conditions, to get a real estimate of service life. If anyone got a real estimate of service life, then we can understand when people talk about service life extensions, what that really means. And then at the bottom here, it doesn't really matter what the sort of design service life will be, even performance, it greatly depends on how well it was put in the first place. So we don't want, if we can at all help it, have reduced digs, for example, which might take 10 years off the life of the ballast for an hour's extra work, say. So just some things on what S&C, what we mean by what good look like, so to speak. So this is an analysis of track geometry against ballast fouling. Don't take the absolute values of it. It's more the trend that I'm interested in, because, as you may know, getting actual measurements of S&C geometry is extremely difficult. So these are estimates. Even now, even with the linear asset decision support tool, which is, has everything lined up, it doesn't actually line up very well with the S&C at the moment. So we're still having to work on that. So that just shows that for hardwood, gradually gets worse as you go through life, even though, as I'll show you later, we're tamping a lot more here, obviously, than we're tamping here. But of course, when you get to a point where if you keep on tamping, it's actually going to make the ballast worse and worse and worse. And then it's choked. I mean, some of this stuff we've got in is 60-year-old, 70-year-old S&C, is basically on peat, really, rather than ballast. Now, the problem appears to be even more extreme for concrete. So this is first part of its life. Ballast is relatively clean. Still don't have very much in good. I mean, that's satisfactory at that point there. But then when it gets a bit older, it seems to go off fairly rapidly as it gets as the ballast gets older, until we don't actually have very much older than that. And a lot of that is because the concretes tend to be on faster line speed, so it's harder to get in, to keep it satisfactory, etc. But it may well be that actually concrete isn't so forgiving of poor ballast as well on the S&C. And I hate to agree with Mr. Hickman there, but he's been telling me that for a while. And it's just as bad for the NR60 as well. Looks pretty decent, fairly new, but then starts to go off fairly rapidly after a while. Some of that is because we can tamp a bit more regularly, because we're not tamping regularly on this low track category stuff. But of course, at the higher track category, we can only get in so often anyway. So even though we might like to do more tamping, or we might want to move to stone blowing, if we have the stone blowers, then we can't. So even though this stuff is getting worse, we're not actually tamping it any more often, because we can only go in so often, and it's only going to damage the ballast anyway. So that's one of the reasons it goes off on the faster on the higher line speed track. Let's put this one in just to show the variation of service lives that you get. This is that nominal used life that I put in those curves. But you can see that even on a nominal used life, we're replacing 3% a year. That's under half its nominal used life at the moment. Some of that is because this stuff here is mainly remodelling stuff, but that one is genuine stuff that is actually needs renewing. Some of that's because it's got very high performance targets, and some of it is because it's not been very well maintained and just had to be renewed. I like to use the word extended rather than expired at the end, because if I put expired, or I'll say, why have you got 20% of your track expired? So I always like to say extended. And it's a fair description, because those numbers were an average. I would expect some things to last longer than average. And something to confirm the gauge, the wide gauge problem that we had. This is based on the gauge assessments that we did after Lambrig, which possibly weren't as accurate as we might like, but nevertheless, this is the number of points failures that we get, or in fact POE failures to be more exact. And this is related to how many are, how out of gauge the points, the switches were. And you can see that even at 5 millimetres, we get 25% more points failures, and once it gets past 8 millimetres, it goes absolutely berserk, and we get loads. And so that shows the what we can achieve if we get our points into gauge. And as we were saying earlier, we're talking of the order of £10,000 per point failure on average for Schedule 8 costs, and we have at the order of about 3,000 a year. So, what specification are we expecting? Now, a lot of this comes from the work that we did for the asset policy book. Generally, we'd be expecting, if we did a heavy refurbishment, we would reduce our maintenance costs by the order of 20 or 30%. So that's the difference we have at the moment between midlife costs and fairly new costs. Some of them aren't really going to change. Inspections not going to change because most of our inspections are S&C are cyclic. We're trying to move to a risk-based inspection. We're doing whole life cost assessments for those. But it's very difficult to get those for S&C. We expect to do, as I showed you on that graph earlier, we expect to do 30% less ballast treatment. And you compared the half-life compared to the new. We expect bearers not to have to be replaced pretty much at all for the next few years because we do those as part of the heavy refurbishment. Rail defects expected to go down, where SO 53, 54 are expected to improve, etc. Now, point of contention is that in our estimates for heavy refurbs, we didn't put any major ironwork in because we said that was part of the maintenance costs. And that has proved a bit of a difficulty for some engineers. So, so when we put a cost in of, I can't remember, it's sort of the order of 70,000 or something like that, that didn't include ironwork at all. We just said that would come out of the maintenance charge because you're going to do that anyway. We might change that for the next time, just to make it clear it is part of the refurbishment at times. But if we do change that, that means you have to take it out of the maintenance budget. Which is, the reason, it is quite difficult to take things out of the maintenance budget. They have a budget, and then if you just say, well, yeah, we've got that much money left, it actually doesn't necessarily mean that they can find that saving very easily. They have to virtually sack people to save money in the maintenance budget, and that's not easy to do if those people are doing a useful job in some other form. So we need to have those, be careful about how we specify that. And finally, service affecting failures. So we'd expect track faults and points faults to be pretty much as new. So we'd expect them to drop right down. They might rise more rapidly than they did when it was a brand new S&C, but nevertheless we'd expect that to rapidly decrease. And generally, when we're costing them, that's going to depend on where it is. So we have some points failures that might cost £1 million, and many, many points failures, probably about 2/3 of them don't cost anything at all in terms of Schedule 8 costs. So costing is actually extremely difficult. Maintenance costing is especially difficult, and we've pretty much been told by finance that we should try and get rid of the concept of maintenance unit costs, MUCs, because that's not how maintenance does its costing. That means that's going to be very difficult for us to do when we're trying to look at individual activities. So if we're saying, oh, we're going to have to do half the number of S&C treatments, we have to somehow say, well, how will that affect the sizing of the maintenance operation? Will it affect the sizing at all if those S&C treatments are going to be done as part of the medium refurbishments as well? The other ones on here, so renewals, obviously that's going to cost depending on site access, etc. So we're talking, what is it, £1 million at point end at Watford Junction, and maybe we can get it down to £250,000 Ian promises me for the NR60. You'll be looking forward to that, I'm sure.
Yeah.
But that will depend on the site, because obviously a lot of them, if you have to duplicate for remodelling, that's going to be expensive. Yeah. Well, we promised ORR that we get it down to £250,000 by the end of CP5. So that's. I'm not saying that's your promise, Steve, but it's as good as.
It's a good good job I've got the right reply.
I'm not going to deny we were criticised by IP for some of my costing. So this is just an example. So this is say we're doing a renewal. We're getting a, this is our service risk cost. So this is quite a critical area. So we'd expect the service risk to be fairly low early on and then gradually increase. We'll do the renewal and we'll start again. So that's what we call a life. So the life cycle is to there. We've got a 31-year life and we're just renewing at that point. And one of the things we want to decide is, well, is it worth trying to do a midlife refurb? So in the dark is the midlife refurb. So 20 years in this, we've done a refurb, a heavy refurb, where we have cleaned the ballast out using the new railback machine, which we also hope might work on the concrete ones as well. Maybe we'll ask that later. So get this down, we'll expect service risk to go down very rapidly, maintenance cost maybe 30% less, but those costs will again go up again and then we finish here. Now this is just an example, it might not be the same for every S&C at all, but those are the costs that we've put into the model and get these numbers out in terms of the total costs. Now you can see this flattening off. The reason it flattens off is because we use something called a discount rate, which is mandated by the Treasury. So any costs in the future are less important than anything costs now. So if you're looking at a cost that is, say, 20 years in the future, it's only going to be of the order of half as important. So we're going to halve that cost compared to what it is now. So if we can extend life by 10 or 20 years, that can be very, very cost effective in what we're looking at. So, summary. Carried out those whole life cost assessments for the current asset policy. We believe the current asset policy is fairly efficient in whole life cost terms. So as long as you follow the policy and you can keep to that cost and keep to the overall budget and do it in the right place, then we will consider that to be a whole life cost optimal solution. However, you've got to work out where that right place is, and we're trying to produce some tools that will help you do that. And we will be issuing those out in the next 3 months, which will basically have things like the cost over the life cycle, the difference that it makes on service life for various performance targets, various ground conditions, etc. And we will be providing help and advice as required. We're hoping also to get some whole life cost specialists in each of the asset teams, but we are being stymied by general reorganisations at the moment, so that might take a bit longer than we'd hoped. Okay?
Brilliant.